collisions and energy transformation. Today we shall be looking at collision and energy transformation. What do you understand by what collision and energy transformation? We'll take them one after the other, okay? Clap your hands. When one hand hits the other, what do you say is happening? You say they are colliding. Say colliding. So that is what it means when we say collision. Collision simply means to collide. What does to collide means? When two objects come together, it's called what? Collision. Now, what we want to study is how is energy involved in collision. Do you think energy is involved in collision? Of course, energy is involved in collision. Is it not? Yes, energy is involved in collision. Look at this. This is a moving object. It have what? Energy of motion. True or false? True. One object is moving. That is what we know. Is it not? For an object to collide, one object must be moving, like you are seeing here now. So what will happen in this is that a bowling ball that has motion energy, as it rolls along the lane towards the pin, we hit the pin, and then the pin will do what? We fall. Is it not? Why is it falling? Because the energy of the ball is now being transferred to the pin. Do you see it now? And this process of the energy of the ball being transferred to the pin is what we call collision. What would happen if two bowling balls smash into each other from opposite direction? This time I will now have two bowling balls. One is coming from the right, the other is coming from the left. When they come and smash each other, we say they have collided. And when they collide, the colliding balls would bounce off each other. That's one thing that will happen. Not only that, then they will also change their motion. It is going to affect their motion, is it not? Yes. Not only that, then the speed and the direction of each ball would also be changed. That means their speed will be changed, and then their direction will also be changed. So the energy of motion will cause changes during this collision. Why? Because energy is what? Involved. I will say energy is the ability to do what? Cause a change, is it not? Yes. Now, collision can change an object shape. Do you believe that collision can change an object shape? Yes. If a glass falls on the ground, what happens to the shape? It will what? Change, is it not? An object in motion has energy. True or false? In a collision, that energy can cause many kinds of changes, not just changes in motion. Now imagine you have a lump of clay, and then this clay you rolled it into a ball shape, okay, and then you now throw it with force against the wall. You will hear a splash sound, is it not? What happens? The mud will stick to the wall. Why did it stick to the wall? Because it has collision energy. Now the energy of motion causes a different change. First, the motion of the clay ball stops, and then the shape of the clay becomes as flat as a pancake, is it not? Sometimes some of the clay will fall down. Why? Sometimes none will fall down. They will just stick to the wall flat. So when we talk of collision actually changes an object shape, you need to get the full understanding of it. Can you see it now? This fine car now collides with this wall, and then what happens to the shape? The shape is totally what? Change. This car in the picture is built so that front part changes shape more easily than the what? Parts closest to the passenger. So why the front part may change shape? The part closest to the passenger for the safety of the what? Passenger. Now, many collision make sounds. True or false? True. When you clap your hand, you hear what? A clap sound. When a two car crashes to each other, you hear a crash sound, is it not? When a glass falls on the ground, you hear a crack sound, is it not? Yes. If a baseball and a bat collide with each other, you hear what? A crack sound. What about a splat? When an egg and the floor collide, you hear a what? A splat sound. Why a bong sound is heard when a mallet collide with a drum. Now, collision often produce sound, and you know what sound is it not? Sound is what is here when you hear when something not vibrate or when an object vibrates. Why are we hearing this sound? Because in the process of this collision, the motion energy of the mallet is transferred to the drum, and then the impact is felt, or we know, by the changes, which is the sound we hear. Is it not? Yes. The motion energy transfers this to the drum. Some of this energy collide, and then as it collides, some of the energy are transferred to sound energy, which we hear. Now think about collision in space. Do you think collision happen in space? Yes, collision occur in space, right? This picture you are seeing here is a picture of two galaxies. Okay, these galaxies are made of gases. What they do is that they collide. When they collide, they will die. But when they die, they will not just die like that. They will be reborn. What do I mean? They will form a new galaxy. So we experience this kind of thing in space. Speed affects collision. That's what you must know. Speed affects collision. What is speed? You already know what speed is, not? Speed is how fast an object is moving. Speed is distance divided by what? The time. Speed is measured in kilometer per hour, is it not? Distance up, time button, is it not? And then you write the unit, kilometer per hour. Now, imagine you pick an object, as you are seeing on the picture. You throw it with a little energy. What happens? It will hit the tree and fall back to the floor, is it not? Now look at the boy in the second picture. He went back, used all his force and threw it against the tree. What happened? Did he fall down? No. Why? Because the first boy has less speed, and therefore we have what? Less energy. True or false? True. Remember we said the more the speed, the more the what? Energy. And the more the energy, the more the what? Speed. Is it not? Yes. Now, look at the same boy using all his energy to give it speed. Do you see the ball hanging on the second tree? Yes. So what you understand from this now is that the speed will cause a greater collision. Okay, the impact of the collision will be felt. You know what the impact is? The impact is the result. Okay, weight affects the changes caused by collision. So we are looking at speed, we are not talking about the weight. If somebody pick a cotton wool and throw it to your head, you will be laughing, is it not? Yes. But if somebody pick a rock and throw it at your head, it is a different story, is it not? Yes. If the cotton ball and the rock are of the same size and they are moving at the same speed, the rock will have a greater energy of motion. True or false? True. Remember I taught you about a trailer and a sport car, is it not? I said if a trailer and a sport car are moving at the same speed, who will have more energy? You people said it's the trailer, is it not? Yes, it's the same thing here. So the reason is that the rock weighs more than the cotton ball, is it not? Yes. And then the motion energy of the rock will cause more collision damage to your head than the cotton ball. Why? Because it has more energy and therefore it has more collision impact. Now, in space, each moon crater offers evidence that motion energy during collision causes change. Objects in space, such as meteoroids, have been crashing into the moon surface for millions of years. What do I mean? This is what I mean. In space, there's what we call meteoroids and asteroids. They are small rock. They also have large sizes. They move and then they collide and then they break and then they form apart again. Some of them falls down. When they fall down, they collide with the moon. Can you see the crater? Yes. The deeper the hole, the more the energy of that meteoroid that caused it. Is it not? Why the smaller the hole, the less the energy of that crater that what caused it. So this is another example in space to tell you that the weight and the speed affects collision. Is it not? Yes. Now we have been talking about energy. How can energy transformation solve problem? When we talk of energy transformation, we're talking about the change of energy from one form to another. Okay? When we talk of energy, we're talking about the change of energy from one form to another. How do energy transformation help people? Look at this image. Imagine you are in the time of Moses and you want to eat toasted bread. Will it be possible? No. Why? Because as at then there was no electricity. So engineers are people who use science and technology to make things that people want or need. To an engineer, anything that people want or need presents a problem which needs to be solved. Okay, all kinds of problems can be solved through the design of new devices, is it not? Yes. Let's take an example. Look at this toaster and then look at an alarm clock. These two objects help people, true or false? True. The toaster helps you to eat a very sweet bread. The alarm clock helps you to know time, is it not? It is somebody that wake up and said, people will need this thing, but for the person to be able to design it, the person must have an understanding of what? Energy, because energy is the ability to cause a change. So every change you need in this world, you need to understand energy. Therefore, engineer also know, as also you know that energy can transform or convert from one form to another. When bowling ball collides with the pins, some of its energy of motion converts to sound. Is it not true? So if somebody wants sound energy, for example, it can do that. Is it not? Yes. Now, conversion occurs when energy changes from one form to another. You already know that. And people use what they know about energy changes to design and build devices that make use of this energy transformation. These devices can make life easier, more productive, and even just more fun. Look at this. This is your clock, okay? People need to know what the time is. That is a problem, is it not? Yes. Now, what is the solution? Mechanical clock can use their spring to store energy. That energy they store, they now transform it into motion energy of the moving hands of the clock, is it not? And as the clock hand move, it tells the time. True or false? True. Do you see how they now convert stored energy into motion energy? Yes. And the motion energy also produces sound energy, is it not? Yes. People need electricity to power many of their devices. They use what? That is a problem. So the solution we bring is what? Generator, which convert what? Motion energy from this spinning part into what? Electrical energy. Not only that, transforming stored energy can help solve a lot of problems, is it not? Take for example your batteries. Without your batteries, many things will not be possible. Your phone will not be able to stay for long, is it not? Your rechargeable batteries are especially useful for small portable devices such as your mobile phone, is it not? A cell phone, for example, converts stored energy in the battery to electrical energy. The electrical energy from the battery transforms to sound, which you use to make call, light, which you use to see, and of course motion energy when the phone is what? Vibrating, is it not? Yes. So people want to be connected to other wherever they go. The solution is what? A smartphone with rechargeable batteries. Store electricity and transform it to what? Sound, light, and motion. So transforming light energy can help solve problem as well. Okay, think of your inverter at home, is it not? Think of your inverter at home that uses what? A solar panel. It is somebody that said we can actually use the light energy from the sun and convert it into what? Electrical energy which people need, is it not? That is why we now have the solar panel today. Look at these two objects. This is a solar panel. The one by my left is a solar panel that is generating a whole city. It's giving light to a whole city. Can you see it? While to my right is an international space station. An international space station is a spacecraft that scientists use to do research in space. Now, you know you cannot come down from space to go and get fuel to put on the on the space station, is it not? Yes, it will take a lot of time and waste a lot of money, is it not? So what do? You don't need to worry yourself. They use energy from the what? Sun, is it not? Which is called your solar panel. Alright? So that solar panel or your solar, how do you call it? You know what I'm saying, is it not? It now converts the light energy into electrical energy, which is used to power the International Space Station. I want you to watch this video and then you learn more about collision, is it not, and the energy transformation.
And today we'll explore the science behind the energy of moving objects. With Dr. Jeff. We're going to demonstrate a type of energy transfer called a collision. It's when one object runs into another object. Izzy, you're going to be our stationary object, which means you're just going to stand there. Mom, you're going to be our moving object, and you're going to run into Izzy on the other side of the gym.
Okay.
Team, any thoughts on what's going to happen?
I think that when Dr. Jeff's mom runs into Izzy, he'll fly back and she'll stay in place.
I think we'll both fly back.
Let's find out. Ready? Set. Go! Zoe, you were right. We just saw the transfer of energy by a moving object, and it happened when the two objects collided. The energy of one was transferred to the other. That's why one stopped moving and the other one started moving.
Welcome back from that video. You now know that collision involves change in motion, is it not? Yes, when objects collide, they change in motion. You now know that collision can change an object's shape, is it not? Yes. And you also know now that many collisions make sound, is it not? Yes. And you now also know that speeds affect collision, true or false? True. You now also know that weight affects collision, true or false? True. The more the speed, the more the collision. The more the weight, the more the impact of the collision, is it not? And finally, you now know that energy transformation helps people, true or false? True. That now brings us to the end of this lesson. Remember to complete other activities in this lesson. Stay safe. I'll see you soon.